Imagine flying a helicopter through a wide river valley. The sky is perfectly clear, visibility stretches for miles, and the air ahead looks completely open. But suspended across that empty space is a transmission line carrying enormous amounts of electrical energy, hanging hundreds of feet above the ground. From the highway below, the danger seems obvious. The towers are easy to spot, and your brain automatically connects the cables between them. But from the cockpit of a moving aircraft, that same cable can almost disappear. Against mountains, forests, rivers, or a bright horizon, a wire only a few centimeters thick blends into the background so effectively that a pilot may not notice it until there is almost no time left to react. That created a unique engineering challenge. Not how to generate electricity more efficiently, and not how to build stronger towers, but how to make an almost invisible obstacle impossible to miss. The solution was surprisingly simple. Large colored spheres attached to selected transmission lines. Known as aerial marker balls, these orange, white, or yellow markers warn pilots that a cable crosses their flight path, especially where helicopters and other low-flying aircraft operate. But their real purpose reveals something much deeper about engineering. Sometimes the greatest danger isn't a machine failing. It's the limit of human vision. A transmission cable can supply electricity to thousands of homes, yet from the air it occupies only a tiny fraction of a pilot's field of view. The human eye naturally detects large shapes, strong contrast, and movement, while a thin, motionless wire can blend almost perfectly into its surroundings. For a pilot flying through a valley or following a river, attention is already divided between altitude, speed, terrain, weather, navigation, and other aircraft. The towers may stand out clearly, but the cable stretched between them often does not. That's why aircraft rarely strike the towers. They strike the invisible span connecting them. Engineers realized they didn't need to redesign the power line. They simply needed to redesign what the pilot noticed first. Instead of making the cable thicker, they placed highly visible markers along it, creating a visual pattern the brain can recognize almost instantly. The wire itself never changes, but suddenly it becomes much easier to see. This also explains why these markers aren't installed everywhere. A transmission line running through a city already has buildings, roads, and towers that help reveal its position. But a cable crossing an open river, a mountain pass, or a wide valley has very few visual references, making it far more dangerous for low-flying aircraft. That's why you'll usually find these markers near airport approaches, helicopter routes, river crossings, major highways, and mountain valleys. They're not protecting the electrical system. They're protecting the airspace around it. But this raises an even more interesting question. If the goal is simply to make a wire visible, why did engineers choose a sphere instead of a flag, a flat panel, or another shape? Because that simple decision reveals just how much engineering is hidden inside an object that most people never notice. At first glance, an aerial marker ball looks almost too simple to deserve so much attention. It's just a bright sphere attached to a cable. In reality, every part of its design exists for a reason. If the only goal were visibility, engineers could have used flags or flat warning panels. But both have a weakness. Their appearance changes with viewing angle, and from certain directions they can almost disappear. A sphere doesn't have that problem. Whether an aircraft approaches from the front, the side, above, or below, it always presents the same recognizable shape. It never needs to rotate toward the pilot, and it remains easy to identify from almost every direction. The geometry itself creates reliability. Its color follows the same engineering logic. Orange, white, and yellow aren't chosen because they look bright on the ground. They're selected because they create strong contrast against the backgrounds where transmission lines become hardest to see. Forests, rivers, mountains, snow, or even a bright sky can hide a thin cable, but a high-contrast sphere immediately interrupts that scene and catches the eye. Engineers aren't making the wire larger. They're making the brain recognize it sooner. Even the spacing between the markers is carefully calculated. Place them too close together, and they add unnecessary weight, wind loading, and installation costs. Place them too far apart, and the pilot may not recognize the cable in time. The goal is to create just enough visual reference for the brain to instantly trace the invisible line between the markers. Size matters for the same reason. From the ground, these spheres often look surprisingly small. But many are nearly 1 meter in diameter, giving pilots valuable extra seconds to identify the obstacle, understand its direction, and safely change course. Those few seconds can make all the difference. Yet making the marker larger creates another engineering challenge. Transmission lines are already designed to withstand carefully calculated mechanical loads. Every object attached to the cable adds weight, catches more wind, and changes how the conductor behaves during storms and temperature changes. So engineers have to find the perfect balance. Large enough to save lives. Light enough to protect the structure. That's why aerial marker balls are built from lightweight, UV-resistant materials that can survive years of sunlight, heavy rain, freezing temperatures, strong winds, and constant vibration. Their mounting systems clamp securely to the conductor while allowing the cable to expand, contract, and move naturally. What looks like a simple plastic sphere is actually the result of structural engineering, material science, aviation safety, and an understanding of how human vision works together. And that leads to an even bigger question. If these markers are so effective, why don't engineers install them on every transmission line? If these marker balls can prevent deadly aircraft collisions, the obvious question is this: why not install them on every power line? Because engineering isn't about adding more. It's about solving the right problem in the right place. Most transmission lines never become an aviation hazard. Commercial airliners cruise far above them, and many power lines cross areas where low-flying aircraft rarely operate. Covering every span with marker balls would add unnecessary weight, increase maintenance costs, and create extra wind loading without delivering a meaningful improvement in safety. So engineers start with something more important than construction. They start with risk. Before a single marker is installed, they study flight paths, helicopter routes, airport approaches, river crossings, mountain valleys, and emergency air corridors. Wherever a pilot is most likely to encounter an almost invisible cable, that's where the markers go. In other words, the marker isn't protecting the power line. It's protecting the airspace around it. Installing them is another engineering challenge. Many of the transmission lines that need these markers cross deep valleys, wide rivers, forests, or remote mountains where cranes simply can't reach. In those locations, helicopters often carry specially trained line workers directly to the cable, allowing each marker to be installed with remarkable precision while the aircraft carefully holds position beside the line. What looks simple from the ground is anything but simple in the air. But perhaps the most remarkable part of these markers is what they don't contain. There are no batteries to replace, no sensors to calibrate, no software to update, and no electronics that can suddenly fail. They simply remain visible, day after day, year after year. And that reflects one of the oldest principles in engineering. The most reliable solution isn't always the most advanced. Sometimes it's the one that performs a single job exceptionally well, with almost nothing that can go wrong. That's why these colored spheres have changed very little over the decades. Their design already achieves an exceptional balance between visibility, durability, cost, structural loading, and long-term reliability. They don't make power lines stronger. They don't improve the electrical grid. They don't make aircraft fly better. They simply solve one dangerous problem with extraordinary efficiency. The next time you drive beneath those orange, white, or yellow balls hanging high above the road, you'll know they aren't decorations or electrical equipment. They're a quiet reminder that some of the world's smartest engineering solutions aren't the most complicated. They're the ones that understand people just as well as they understand technology. Because great engineering isn't always about building something bigger or more advanced. Sometimes, it's simply about making the invisible impossible to miss. If you enjoyed uncovering the hidden engineering behind something millions of people pass every day without noticing, subscribe to VIRESIA. And tell us in the comments, which everyday engineering mystery should we uncover next?